Hello my viewer, it is an honor having you on board. This is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Please join me for this lesson, learn, understand and enjoy maths with me. If you are new to our channel, please remember to subscribe to be our student and get our future lessons immediately they are released. Welcome to the second lesson in the series Matrices. In this lesson, we are going to learn methods of calculating inverses of 3x3 matrices. We start by a definition of what an inverse of a matrix is, and we say that for a square matrix A, we say it is invertible if there exists a matrix A raised to power minus 1 such that A multiplied by A raised to minus 1 is equals to A raised to minus 1 multiplied by A, which is equals to identity matrix. The first method we are going to use in determining inverses is the cofactor method. We are going to start by a definition, that is, if A is a square matrix, then minor of element Aij, also called the ijth minor of A, is denoted by Mij, and it defines the determinant of submatrix that remains when I row and jth column are deleted from A. The number Cij, which is equals to minus 1 raised to I plus j multiplied by Mij, is called the cofactor of element of A. The inverse of matrix A is given by A raised to minus 1, which is equals to 1 over determinant A multiplied by adjoint of A, where we have adjoint of A is equals to transpose matrix of the cofactors. The steps we are going to follow in calculating the inverse of a matrix by these methods are: number 1, we are going to determine the determinant to know if A is invertible. 2, we calculate the minus and the matrix M of the minus. Number 3, we convert the matrix of the minus to matrix of cofactors. Number 4, we determine the adjoint of A, and lastly, we determine the inverse. Example number 1, by cofactor method, we determine the inverse of A if A is equals to 3 minus 2, 4, 3, 4, 1, 2 minus 3, 5. For us to do so, we are going to start by determining the determinant to know if A is invertible, and we have determinant of A is equals to A11 multiplied by C11 plus A12 multiplied by C12 plus A13 multiplied by C13. To calculate the cofactors C11, C2, C12 and C13, we first of all calculate the minus, and we have the minor M11 is equals to 4, 1 minus 3 minus 5. M12 is equals to, we delete row number 1 and column number 2, and you're going to be left with 3, 2, 1 minus 5. And M13 is equals to, we delete row number 1 and column number 3, we're going to have 3, 2, 4 minus 2, and this is equals to minus 20 minus 3 is minus 17, minus 15 minus 2, another minus 17, so minus 9 minus 8, again another minus 17, which implies that C11 is equals to minus 17, C12 is equals to 17, and C13 is equals to minus 17. Therefore, determinant of A is equals to 3 multiplied by minus 17 plus minus 2 multiplied by 17 plus 4 multiplied by minus 17, and this simplifies to minus 153. Hence, we say that A is invertible. We determine now the remaining minus. We have M21 is equals to M21. We draw row number 2, column number. We are left with minus 2 minus 3, minus 2 minus 3, 4 minus 5. Get the determinant. M22 is equals to M22, row number 2 and column number 2 out. So we have 3, 2, 4 minus 5. M23 is equals to 3, 2 minus 2 minus 3. Therefore, M11 we get minus 22, M22 we get minus 23, and M23 is equals to minus 5. C12 is equals to minus 1 raised to 3 multiplied by minus 22, which is equals to minus positive 22. C22 is equals to minus 1 raised to 4 multiplied by minus 23, which is equals to minus 23. C23 is equals to minus 1 raised to 5 multiplied by minus 5, and this is equals to minus 5. For the next set of minus, we have M31, and this is equals to, we broke row 3 column 1, 4 minus 3, 1 minus 5. M32, we broke row number 3 and column number 2, we have 3 2, 4 minus 5. M33, we broke row 3 column 3, we have 3 3 minus 2 4, which simplifies to M31 reduces to minus 18, M32 is equals to minus 9, M33 is equals to 18, and the corresponding cofactors C31 is equals to minus 1 raised to 4 multiplied by 18 minus 18, this is equals to minus 18. C32 is equals to minus 1 raised to 5 multiplied by minus 9, which is equals to 9, and C33 is equals to minus 1 raised to 6 multiplied by 18, which is equals to 18. Thus, the matrix of cofactors C is equals to minus 17, 17, minus 17, minus 17, 17, minus 17, 22 minus 23, minus 5, minus 22, minus 23, positive 5, and lastly, minus 18, 9, and 18. Now the inverse of A is therefore equals to 1 over determinant of A multiplied by the adjoint matrix of A, which means that the inverse of A is equals to 1 over determinant of A. Determinant was minus 153. Adjoint, we take the transpose of C, that is minus 17, 17, and minus 17, minus 22, minus 23, and 5. Lastly, we have 18, minus 18, 9, and 18. Our second method, we are going to look at the gauss-jordan elimination, which involves creating an augmented matrix of A with the identity and then converting matrix A to become the identity. For us to perform gauss-jordan elimination, we are going to be guided by the following steps. Number 1, we write the augmented matrix with the identity matrix. Number 2, we swap rows so that all rows with the zeros entry are on the bottom. We swap rows so that all rows with the largest leftmost non-zero entries are on top. Multiply rows, we multiply top rows by scalars so that top rows leading elements come 1. We add or subtract multiples of top rows to the other rows so that all the other entries in a column containing the top rows leading elements are all 0. We repeat step number 2 and 4 for the next leftmost non-zero entry until all the leading entries are 1. Number 7, swap rows so that the leading entries of each non-zero row is on the right of the leading entry of the row above it. Our first example under gauss-jordan elimination method is our second example in the lesson, which is A is equals to 1, 2, 3, 2, 4, 5, 3, 5, 6. We determine the A inverse. The first thing we are going to do, we write matrix A augmented with the identity. We have 1, 2, 3, 2, 4, 5, 3, 5, 6, augmented with the identity matrix 1, 0, 0, 0, 1, 0, and 0, 0, 1. What we're going to do is we maintain row 1 as it is, so row 1 still remains as it is. Row 2 we still retain as it is, whereas we make this 3 to be a 0, and for us to make the 3 be a 0, we have row 3 becomes row 3 plus minus 3 row 1. Hence we have row 1 and row 2 remains, so we have 1, 2, 3, 1, 0, 0, 2, 4, 5, 0, 1, 0. Then row 3 becomes a 0. Then we have 5 minus 6 becomes minus 1, and 6 minus 9 becomes minus 3. On the other side we have minus 3. This is a 0 and this is 1. Then at that point row 1 still remains as it is. Row 2, we remove the 2 at row 2, so row 2 will be equals to row 2 minus 2 row 1. Row 3 remains as it is, and that would give us, we have 1, 2, 3, row 1, 0, 0. Row 2 will therefore become, this becomes a 0, this is also a 0, minus 1. Then on the right hand side, this is a minus 2, this is a 1 and 0. Row 3 remains. We have 0 minus 1 minus 3 is equals to minus 3, 0 and 1. Now we argue, we retain row number 1 as it is, and we interchange row number 2 and row number 3, and that will give us 1, 2, 3 into 1, 0, 0. Row number 2 becomes 0 minus 1 minus 3 minus 3, 0 and 1. Row 3 becomes 0, 0 minus 1, and this is minus 2, 1 and 0. We now reduce this 3 to a 0, whereby we have row 1 just remain as it is, row 2 is equals to row 2 as it is plus 3 row 3, and row 3 remains, and that will give us 1, 2, 3. The other side we have 1, 0, 0. Row 2 will become 0 minus 1, 0. Right hand side we are going to get 3 minus 3, 1. And then the row 3 remains 0, 0 minus 1 minus 2, 1, 0. Now the next thing we'll do is we reduce the 3 to a 0, which now will mean that row 1 is equals to row 1 plus 3 row 3. Row 2 will be equals to minus row 2, and row 3 will be equals to negative of the current row 3, which will give us 1, 0, 0. Right hand side we have 1 minus 3, 2. Row 2 becomes 0, 1, 0. Right hand side we have minus 3, 3 minus 1, and row 3 becomes 0, 0, 1, 2 minus 1, 0. Now that we have succeeded now to write an identity matrix in the position that was there for A, then it will mean that our A inverse is simply equals to 1 minus 3, 2 minus 3, 3 minus 1, 2 minus 1, 0. This is Dixon again from Mathswiz. It is my hope that you have learned, understood and enjoyed the lesson. Please remember to subscribe to our channel and give us your feedback from the lesson. Thank you for your watching.